How you doing? Today I'm going to show you how to do completing the square using algebra tiles. I think it's going to go really well. But then again, I'm here all alone doing math problems and filming it. So what do I know? Before we start, you got to know what each tile represents. The big guy is x by x for an area of x squared. The rectangles are measured by x across and 1 down. That's an area of x. And the little guys are 1 by 1s, so each area is 1. And if you find that you're doing a problem where you need something negative, well, the other side of these are negative. I hate math! I told you. So here's what we have. We're going to need 1x squared. We're going to need 4 of these x tiles, and then we'll need 5 of the little guys to make our 5. And the goal is to build a square kind of like this. You can turn these to measure them up x by x, and I'm going to turn these here. So that was my attempt at making a square shape overall. But I'm off by this little corner that's missing. So what I can do is start filling these gaps in. These are going to be 1 by 1 squares, and I'm almost going to use all of them, but I actually have an extra one. I'll leave him right here. What we actually have done is rewritten the problem so that it's x plus 2 more this way, and x plus 2 more this way. So here's the square that we completed. X plus 2 by x plus 2, better written as x plus 2 quantity squared. But we still have this little guy over here, so we're going to tack him on, and he's worth 1. So this statement right here is equivalent to this one right there. And that was our goal. Okay, so here we have a tougher problem because it has some negatives in it. But all I did was I flipped the tiles over, and now they represent negative amounts. So I'm going to do the same thing as before. I'm going to try to get as close as I can by putting these tiles pairs on each side, and I find that I'm off by a similar amount from last problem. However, since these amounts here and here represent negative numbers, this area can't be filled in with these. It wouldn't make sense, because a negative times a negative is going to be positive. These need to be positive areas, but we don't have any. So what do? We materialize these out of the blue, and we fill them in. So if I slide them in where they go, all looks good. Except you're not allowed to do that. You can't just put a 1 into a problem. You'd be changing the original problem. So how do you counteract that? For every 1 that you materialized, you have to put in an opposite to balance it out and keep the harmony in the nature of the problem. So now, if you look at what we got, we made our square legally by supplying the extra pieces that we didn't have with their exact opposites. So, what does that do for us? It gives us x minus 2 and x minus 2 for a problem that looks like this. Better written as that. There's the square that we completed, but look at all this extra stuff. We have to count it up. 1, 2, 3, 4, 5, 6, 7. There are 7 negatives. Now this is equivalent to this. If you don't believe me, you can multiply it all out. I'd do it for you, but I have better things to do. Who am I kidding? I'm going to do it. Voila! Back to where we started. You're welcome.